All right, so 10.1.1 part 2. I'm hoping this one goes a little more smoothly for me than the last one did. I guess we'll see. So anyways, according to the U.S. Census Bureau, 312.5 million people live in the U.S. in 2011. The number of people living alone is given to a table below. This isn't really germane to anything, but I've been watching Westerns during the pandemic, the coronavirus pandemic, and I think the Western came out in like 59 or 60, show called Maverick, and they mentioned that there were 60 million people in the U.S., and I think now we're at 2020, and I think it's like a 360 million. So you can see how quickly population grows. It's something else. It's truly exponential. Until, I don't know, I guess we'll see. Can't go on forever. Anyway, so this is what we have. This is the amount of ages of people, and this is how many of those people live alone. So what is the probability of living alone? Well, they're essentially asking everybody, hey, do you live alone? So I don't need to go age group by age group by age group. I'm just going to go to the total, and I'm going to divide 32.73 by 312 million. And I'm going to get, again, these are all in millions, 32.73 divided by 312.59. I get 10.47%, so about 10.5% of people live alone out of everybody. So what's the probability of being 65 and older? And again, I have totals here. So these people aren't 65. I don't need to worry about them. These are the only groups of people that are 65 or older. So 65 to 74, but also 75 or older. I need to remember to add those two together and not just see the number 65 and go straight to this column, but also recognize these people are also over that age. So my math is going to look like this instead, where I have to add these together. So 21.4 plus 17.76 equals 39.16. I'll divide that by 312.59, and I will get about 12.5% of people are over the age of 65. And again, I hope that makes sense why that would be the case. So what's the probability of being under 65? Well, think about this. I could either add all these people together and divide by 312, or I can do, again, maybe in the last video you remember, if I didn't cut it out, it's known as the complement. Essentially I made a mistake in 10.1.1 part 1 and I cut out some footage, so I don't know if I mentioned the complement then or not. But long story short, the complement is essentially saying, hey, I know that this group plus this group equals 100%, so if I know that this group is 12.5, I should just be able to subtract and get what's left. So again, the 100% minus the 12.5% that I already know is over the age of 65 should give me, 87.5%, I think. Again, you could add this, and this, and divide by 312.59, and I think you'll get the same answer. Maybe some rounding, but you'll get the same answer. So what's the probability of being under 35 and living alone? So probability of being under 35 and living alone. Again, this is and versus or. So make sure you know the difference. So they have to be under 35. All these people get the under 35 slash. And they have to live alone. All these people get the living alone slash. So if it's and, they need to have both slashes. So I'm going to add those together. So I'm going to get 1.45 plus 4.16. And I'm going to divide that by 312.59. So 1.45 plus 4.16 equals 5.61. I'm going to divide that by 312.59, and I'm going to get 1.8% about. So not a lot of people under the age of 35 living alone, obviously, because so many people are children and so many people end up getting married. Okay, so moving along. Oh, wait, I don't want to get rid of all that, I don't think. Because I think they're going to ask me the or question. Now, on the next one, it says, find the probability of being under 35 or living alone. Kui added the total number of people in the first two columns to the total number of people in the first row. What did Kui do long? So, yeah, okay, so what's going on here is we got a couple things. First of all, if it's or, you could add this plus 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 this, and divide by 312. That's a lot of work. So Kui noticed a shortcut, said, hey, look, all these people live alone. I'm going to add this plus all these people are under 25, and all these people are under 35 and under 35. All these people are under 35. So I'll just add these together. But the problem is he counted these two people twice. He counted them as living alone, and he counted them as being under the age of 35. So rather than take his shortcut, but I do like the idea of a shortcut, so we're gonna sort of change his shortcut a little bit. And instead what we're gonna do is we're gonna take this total, the 32.73, because that's everybody living alone, and instead we're just gonna add the 109.67 and the 37.41. And we'll divide that by 312.59. And again, the idea here is if we take this column total, we're counting this 1.45 twice, and we're counting this 4.16 twice, and we only want to count it once, and it's already been counted here. So just these last two. So now we will add those together, 32.73 plus 109.67 plus 37.41 equals 179.81. We'll divide that by 312.59, and we're going to get 57.5%. All right, now the saddest problem in this book. Refer to problem 10.6 above. Is there an association between age and living alone? Ugh, what a depressing problem. It's not so bad if you don't think about what this entails, but if you go in behind the numbers, you can see it's depressing. So first of all, hey, how many people under the age of 25 live alone? I'm going to divide this by this, right? There are 111 million people that are under the age of 25, and 1.45 of them live alone. So you can see 1.3% of the people under the age of 25 live alone. What about 25 to 34? I'm going to divide these. 4.16 divided by 41.57. And now we're up to about 10% of people 25 to 34 live alone. What about 35 to 44? 3.55 divided by 39.83. We're back down to 8.9%. And that's not really surprising, right? You're in your 20s, your 30s, maybe you're not married yet, you're living alone. Now maybe you get married, have children, whatever. All right, so now we'll go 5.57 divided by 43.94. You're going to get 12.7%. So maybe, we got a little divorce in here and the kids have left the nest. It's going to get worse. 6.69 divided by 36.97. We're up to 18% now. I'm going to leave the analysis alone, and I'll let you sort of start to think about what they're asking high school kids here. Now we're up to 22.5% from people 65 to 74 that live alone. So again, that's at 22. And then what about 75 and older? We're at 6.5 divided by 17.76, and we're at about 36.6%. So is there an association? Yeah, there certainly is. The older you get, the more likely you are to live alone. Older equals more likely to live alone. And again, I'm going to not go too much into detail there, but I will put a sad face. Alrighty, let's go to 10.8. In a recent survey of college freshmen, 35% check the box next to exercise regularly, 33% check the box next to eat 5 or more servings. We'll just call that essentially eating healthy, right? 5 or more servings of fruit and vegetables a day is eating healthy, as it were. And 57% check next to neither. So create a two-way table. So again, when we create a two-way table, I'm basically saying exercise, yes, no. And I am saying healthy eating. Eat healthy. yes, no. And I want to be real clear here. Do not go exercise yes, eat healthy yes, exercise no, eat healthy no. Not a great idea. What makes more sense is exercise, on off switch, yes, no. Eat healthy, on off switch, yes, no. Now, 35% of the student says they exercise regularly. Well, they didn't mention anything about eating healthy. It did not. That has to be a column total. 33% said they eat healthy, but it didn't mention anything about exercise. That has to be a column total. 57 said neither. Well, now we're talking about both. So 57% can go here, and then we have a conundrum. And again, hopefully you're trying these videos on your own and not just watching them. But what's going on here? I said when we solved these things that we needed... my handwriting is terrible. I said when we solve these things that we need to have one missing, right? Here's two missing, can't solve. Two missing, can't solve. Two missing, can't solve. Two missing, two missing, two missing. So something's missing here. And hopefully you are able to figure out that what's missing is that there's 100% of people being polled. Now we can go here and say, well, this must be 65. This must be 67. This must be 10. This must be 25. And this must be 8. So hopefully you're okay with that two-way table and how to fill that in. Now, what's the probability that a freshman who is surveyed exercises regularly and eats 5 servings? So here's exercises regularly. They'll get the exercise regularly. They're going to get the eat healthy. They have to do both because it's an and question, so it looks like 25% do. What's the probability that a freshman who would survey exercises regularly or eats healthy? Well, we got to add up these people plus this extra. So we got 35 plus this 8. We're at 43%. And again, hopefully that makes sense. Let me put it another way. How many people don't do either? 57 don't. Well, that's the complement. 100 minus 57 is 43. So you can either add up the ors, or you can say, well, these people don't, and use the complement. And is there an association between eating fruits and vegetables and exercising? Create a frequency table. Now, it might seem like we already have a frequency table because it's already in percents, but we actually don't. If we're going to make a frequency table here, what we're going to do is we're going to have our exercise, yes, no. We're going to have our healthy eating, yes, no. And then what we need to do is, remember, divide 25 by 35. So 25 divided by 35, we have to divide the column totals. 71% of people eat healthy. So this should be 10 divided by 35, should be pretty close to 29%, and it is. So I'm looking at 29. Now I have 8 divided by 65. I have 12.3 over here. And I'm going to these are all in percents, so hopefully we know these are all in percents. I'm just going to give myself a little more room here. And then 57 divided by 65 is going to be 88, or 87.7. So we would say, is there an association between eating fruits and vegetables and exercising? Well, yeah, it sure seems to be. It seems to be that the people who eat healthy are way more likely to exercise. Okay, hold on a second. The people that exercise are way more likely to eat healthy than the people who don't. So yeah, we'd say yes, association for sure. That says association. Boy, that's really not good. Again, because it's 71 versus 12.3. And again, these are both percents. Looks like I'm running out of room here, so I will go to the next part here. And we will continue problem 9. So problem 9. Is there an association between chores and curfews? In other words, do students who do more chores also have a stricter curfew? I want to make this point. This is fabricated and made up information. It is not necessarily true. So the data for 27 students in the two-way table is shown. Hopefully at this point we can easily put in our totals, and we know it looks something like this. So assume the curfew is independent That means that you should calculate the total number of students who have having curfew or late curfew. Can you then create a frequency table? Then the columns of the curfew will add up to 100%. So essentially what they're saying is they want us to do this. They want us to say early curfew, late curfew, yes chores, no chores. That looks terrible. I'm going to change all of this. So, curfew, early, late, chores, yes, no. Doesn't look great. Does look better, I think. All right, so here is 9 divided by 18. That's going to be 50%. Here is 9 divided by 18. That's going to be 50%. Here, 0 divided by 9. That's going to be 0%. Here, 9 divided by 9. That's going to be 100%. So here's our relative frequency table. I should calculate that. Okay, is there an association? Yeah, it definitely seems to be, right? People who have early curfew are 50% likely to do chores. People who have late curfew are 0% likely. And again, guys, if you don't have a curfew and you have chores, this is fabricated. It's not real information, so there's no point in arguing with it. We're just using it mathematically. But again, yeah, we'd say, yeah, there is an association, 50% versus 0. So yes, 50% versus 0%. Does doing chores depend on whether or not you have a late curfew? So essentially what they're saying is, hey, what if I switch this? Would these numbers be different if instead I divided differently? Right? You can see they move chores up to the top and they move curfews to the bottom. So would that change anything? Let's see. So let's go ahead and make this. We have chores. Yes, no. And we have curfew, early, and late. And we're going to do the same thing that we just did. We're going to make our frequency table. 9 divided by 9 is 100%. 0 divided by 9 is 0%. 9 divided by 9 is 9 divided by 18 is 50%, and 9 divided by 18 is 50%. And you can see, hey, we still have association there. So does changing the independent variable change your conclusion about association? It doesn't. It doesn't matter which one we call as the independent variable. We should get that there is or is not association the same way. Now it says, now consider this new group of 27 fabricated students. For these students, is there an association if curfew is the independent variable? So again, we're gonna make our relative frequency tables for both situations. So first we'll make the first one. I get something that looks like this, and we will get, again, early and late curfew, and then yes chores, no chores. I really am going to go to shorthand now. I'm kind of, okay, so 6 divided by 18 is 33%. By the way, I'll just put this as E and L and plus C and minus C in case you're not listening. And then 12 divided by 18 is 67%. What about over here? 3 divided by 9 is 33%. 6 divided by 9 is 67%. So on this one, I would say that there is no association, right? Those numbers are the same. Now they want us to change it a little bit. Now what they're saying is, all right, what if we flip this? And what if we said, yeah, chores are up here, no chores are here, early and late curfew. All right, so this is chores, this is curfew. How would these numbers change? Well, we would still say that there's 6 kids that do both. We would say that there's 3 kids that do chores that have a late curfew. So that would be a column total of 9. For no chores, we would say 12 have an early curfew and 6 have a late curfew. So again, you can see we just swapped these, just like we did in the part C. And what they're asking us to do is compare again with this table. So we're going to say that if we switch everything, that it's 6 out of 9, it's 67% versus 33%, and it's 67% versus 33%. And again, we come up with the same conclusion that, yeah, it doesn't matter. It doesn't matter if you flip the association or the independent variables. You still get the same association versus not association. Now, what is interesting about relative frequency tables that have no association? Well, the numbers are the same, right? If there's no association, those numbers as a percentage are going to be the same. A little bit tricky. Maybe watch the videos. Again, always feel free to reach out via email if you have questions, and I will do the best that I can to answer them. Have a great day.